Oh, hi there. It's Mrs. Bertrand, and this is acids, naming and formulas. So acids are hydrogen ion donors, H plus donors. So every acid is going to have an H at the start of their formulas, and acids also have to be dissolved in water, meaning they have to have an aqueous state in order to behave like acids. So the other thing you're going to notice about acids is they always have this symbol of AQ as their state after their formula. There are two types of acids. The first is a binary acid. When we're making formulas for binary acids, they always start with H, all acids do, and then we're just going to add a non-metal using the crossover rule. And again, last finishing touch, we'll add an AQ after the formula. In terms of naming, we have hydro at the very beginning, then we insert the element name, and then we put an ic on the end. This is a big name, so I always think of a small formula acid equals a big name because this is a binary acid, which means only two ingredients will be formed. One of them is hydrogen, the second one is that non-metal from the front of the periodic table. Let's do a couple of examples here. So we've got HClAQ, so we've got hydrogen at the front, there's our hydro, and then we've got the ic acid. So the only thing that we're really changing is what do we say about the non-metal. Again, small formula means we use the hydroic acid naming, and so the part in the middle just tells us what non-metal is partnered with the H, because acids always start with H. As soon as you see an H and an AQ, you have an acid on your hands. The second one here, we've got a hydroic acid once again, and so the naming here, big name, small acid. We did a crossover rule here, so let me show you how that would have gone. Hydroic acid. As soon as I see the word acid, it means start with a hydrogen. Hydrogen is in column 1, so a 1+ charge. And then this piece tells me which element to choose. Sulfuric means choose sulfur. So sulfur has 6 valence electrons. It needs 2 more to become a 2 charge. Cross them over, and I make an H2S. And to make it an acid, I have to put an AQ in there. The second type of acids are oxyacids. And again, acids always start with H, so I have an H at the beginning of the formula. But this time, I'm going to partner the H with a polyatomic ion from the back of the periodic table. I still have to do crossover rule. This is still ionic bonding. And then because it's an acid, I still have to put an AQ at the back of the formula. This time the naming is a little bit different. I only have ic acid, a small name. So again, I think of big formula, small name. It's very easy to confuse these two. Let's do a couple of examples and then we'll mess around a little bit with it. So chloric acid, again, small name, big formula. If I'm making a formula here, I've got the answer, but let me show you how it would work. As soon as I see acid, think H. H is in column 1, so it's an H1+. That's the start of the formula. Then I'm going to chloric. Because it's an ic acid, a small name, this means big formula. So I'm now going to the back of the periodic table to figure out what chloric is. You're looking for the closest thing back there called chloric. We don't have chloric, but we'll have something close. So if you look, the only thing that is similar is chlorate. So that is the polyatomic that you want to use. So you're just choosing chlorate, and then you're doing your crossover rule and making your formula. So definitely a little confusing. 1 and 1 I don't have to show, but because it's an acid, I will put that little AQ in there as well. The other example here that we have is a formula. Again, if I start with H and I end with AQ, I should know I'm dealing with an acid. Because it's a polyatomic acid, an oxyacid, this is where I'm just going to be doing an ic acid name, and I need to figure out what the part in front of the ic is. So I'm using the NO3 as the baseline, and if I go to the back of the periodic table, this is called a nitrate. I'm just going to change it into a nitric acid. So I'm just basically morphing this name and then changing it to suit the acid name. A little bit confusing, I know. So we're going to do a worksheet, but I'm going to also do a couple more practices with you just so you can see how this would work. So for instance, I could have hydrophosphate phosphoric acid, and I can have phosphoric acid. Very similar. So we need to know what's what here. The hydroic naming means big word, small formula. Notice that anytime I have the word acid, though, the formulas will always start the same way with the hydrogen 1+. I just have to figure out what we're talking about here. The first one, hydrophosphoric, big name, small formula, means a regular nonmetal. So this means just phosphorus. Phosphorus is in column 5. It needs 3 more electrons. Crossing it over, we make an H3PAQ. Ic acid is a small name, big formula. So now I'm looking for phosphorus, but I'm looking for the polyatomic version. So I'm looking on the back of the periodic table, and I should be able to find something that looks kind of like phosphoric. The only thing back there is phosphate, so that's my only option. Crossing over, H3PO4, and then an AQ. So again, hopefully this example is helpful because it shows you the two similarities and how they are different from one another. Good luck!